Hello, welcome to Smart Way to Success program. In this video, we are going to share with you some important tips in mastering applications of differentiations for mathematics XM 015. The two main subtopics in these chapters are extreme problems and rate of change. There are four types of popular questions in these chapters. First, find the stationary or critical points. Second, find the relative extremum using first derivative test or second derivative test. Third, solve the optimizations problem. Fourth, solve the rate of change problem. Below is a summary chapters for applications of differentiations. The important skills in applications of differentiations is divided into these three subcategories. They are relative estimum, optimization problem, and rate of change. For optimization problem, students have to find the stationary point or critical point. Then, students also have to use the first derivative test or second derivative test to find the relative estimum. For solving the optimization problem, students have to remember to use the first derivative test or second derivative test to determine the maximum or minimum relative. And finally, I will suggest students to use the methods of differentiate with respect to T both side methods for solving the rate of change problem. Students always getting confused between stationary point and critical point. So look at this diagram. So for stationary points, we notice that it will occur when your dy dx is equal to 0. And for the critical points, it will occur when dy dx equal to 0 and when dy dx is undefined. We may use first derivative test or second derivative test to determine the local maximum or local minimum. First derivative test. For relative maximum, there must be a change of signs of gradient from positive to negative. For relative minimum, there will be a change of signs of gradient from negative to positive. It is not a relative extremum when there is no change of signs of gradients. For the second derivative test, the functions will have the relative maximum when the value of second derivative is less than 0 or negative. The functions will have the relative minimum when the second derivative have the value of greater than 0 or positive value. The four simple steps in solving optimization problems are: first, determine the functions to be optimized. Second, differentiate the functions. Third, find the value of x where f prime equal to 0 or f prime does not exist. And finally, remember to use the first or second derivative test to determine the maximum or minimum relative. The rate of change of quantity y with respect to t, whenever you have the value of positive, it means that the quantity is increasing with time t. Whenever you get a value of negative, the quantity is decreasing with the time t. For the step-by-step solution examples, please stay tuned with us in slot 3 Smart Way to Success YouTube channel on 15 December 2020 at 8:30 p.m. The questions that we are going to show you are: Questions 1 on critical point. Questions 2 on local extremum. Question 3 is optimizations problem. Question 4 is rate of change. See you then in Smart Way Southeast YouTube channel on 15 December 2020.